All right, so when we're getting a little bit more advanced with these, let's look at the subtraction, or the substitution, I'm sorry, one more time. So we'll say A is 3, M is -10, and Z is, I don't know, -8. So if I had one that said like the absolute value of -Z minus M plus A. Okay, my first step would be to substitute in, but I have to pay attention again, like we talked about earlier, with this being a -Z. Well, I have a -8, so I still have to put that in there, the negative sign from the Z, and then I'm substituting in my -8. Minus, bring that straight down, M is -10, so I still have to put that in there. Plus A, so that's A is just 3. Bring down your absolute value symbols. Then I'm going to work, I wrote an A, I'm sorry, I should have put a 3. So then I'm going to work everything out inside of here. Since I have just addition and subtraction, I can work it out from the left to the right since they're on the same step for the order of operations. So when I'm taking out 8 bad guys, what's happening there? Emily? Yeah, it's going towards the positive, so plus 8. And subtracting 10 bad guys. Jace, which way are we moving? If I'm taking, we're going to go towards the positive. Good. So this becomes 8 plus 10 plus 3. 8 plus 10 plus 3. And I can't forget about the absolute value. So the absolute value of 21 still is going to be 21. So substitution works exactly the same. The only trick is if there's a negative sign or a subtraction sign that coincides with a negative symbol, I have to record the negative symbol here. That's why there was 2 negatives. I have to record it. There's minus the -10. I have to record both of them. So that's a trick that some people fall to. Don't let that be you. All right, the next kind of problem is like an equation. So you're going to see something that might say 7 minus blank equals -15. Well, I know that you saw this last year, not with negative numbers, but that blank, right, a lot of times we'll just call it X. So 7 minus X means 7 minus something is going to equal -15. Does anybody have a thought? Yeah. You're close. You have, yeah.
If you add 7 to the 7, it cancels it out, and then you would do +7 underneath the 15, and you get -8.
Okay, so I know where you're going. Is last year we looked at this and said that, oh, it's a subtraction problem, so I'm going to have to add, right? But I'm subtracting X, so that's a little bit different. How do I get rid of, if you will, a 7? What's the opposite of 7? Melissa? So I'm going to subtract 7, and I'm going to subtract 7. So that 7 minus 7 is 0. 15 minus 7 would be the same thing as 15 plus a -7. So what's that going to give me? Yeah. Nope. If I owe someone $15 and then I add another $7 to that bill, negative 22. So I'm bringing down my equal sign. Notice I have minus x. We said a subtraction sign and a negative sign are the same. So now I have a negative x is equal to negative 22. So if a negative x is equal to negative 22, what is x? Negative what equals negative 22? That's what this is saying. Negative something equals negative 22. What has to go in for x to make these two sides be balanced and equal? Jacob? 22. X is 22. Because if I put 22 in here, I got negative 22 equals negative 22. Do we see that? I want to do another one because I think we need to. If I said x minus, bless you, negative 5 is equal to 12. Well, one thing that we could start off with is, since I'm subtracting a negative 5, I'm taking out 5 bad guys. Even though I have an x in here, I still know that this is going to be x plus 5 equals 12. Probably looking at that, you could figure out what the answer already is. But in case you didn't know, we would want to do the opposite. So instead of adding 5, what could we do? Emily? Subtract 5. So a positive 5 and a negative 5 is going to make 0, leaving me with x. 12 minus 5 is going to make 7. And refresh my memory, why are we doing the same thing to both sides of the equation? What does this symbol mean? Jacob? It's the same, yeah. So if it starts off equal and I change one thing about one side, I have to change the exact same thing about the other side to keep it equal, to keep it balanced. All right, one other type of problem that I want to show you. So let's say we'll say from 5 a.m. to 6 a.m. we got a change in temperature, and we're going to say the temperature went up 5 degrees, and then from 6 a.m. to 7 a.m. the temperature went, maybe some kind of funky weather came in and the temperature went down 10 degrees. And they tell us at 7 a.m. the temperature was, I don't know, we'll say 50 degrees. I want to know, what is it at 5 a.m.? Okay, so there's multiple parts to this. It's giving us information about the temperature change from 5 a.m. to 6 a.m. It went up 5 degrees. But then storm came in, and from 6 to 7, it went down 10 degrees. 7 a.m., it was 50 degrees. So if I want to figure out to 5 a.m., I need to work backwards. So if I went from 7 a.m. to 6 a.m., how did the temperature change? From 7 to 6, going backwards. I'd want to do the exact opposite thing. This is telling me from 6 to 7, it went down 10. So from 7 to 6, it went up 10. So if I'm starting at 7 a.m., I like to make myself a little chart just to keep track here. So it was 50 degrees. Then when I went to 6 a.m., that went up 10 degrees. Because from 6 to 7, it went down 10. So if I'm going backwards, my temperature had to go up 10 degrees. So at 6 a.m., I'm at 60 degrees. And then from 6 to 5, it would have went down 5 degrees. So at 5 a.m., the temperature is 55 degrees Fahrenheit. So if I'm finding the change in the temperature and they give me an end time and I need to go back to the beginning, you work backwards and do the opposite. I'll do one more like this and then we'll call it good, okay? So let's say at 3 p.m. to 4 p.m., oh, that's not a B, we went down 5 degrees Celsius, and from 4 to 5, it went down 15 degrees Celsius. So something happened, snowstorm came in. And we're saying at 5 p.m. the temperature was 3 degrees Celsius. We want to know what is the temperature at 3 p.m. So again, since they're giving me the end time, I have to work backwards and do the opposite. So if at 5 it's 3 degrees Celsius, right, at 5 p.m. it's 3 degrees Celsius, then to go back to 4, I need to add 15. So I'm at 18 degrees. So that's giving me the temperature at 4 p.m. And then to get from 4 to 3, I need to add 5 degrees. So that's getting me to 23 degrees Celsius at 3 p.m. Not every problem is always going to give you the end result. If it gives you the beginning result, well, then I would just follow this step. So if it told me what it was at 3, the problem said, at 3 o'clock, it was 23 degrees. Then I'd say, okay, I need to subtract 5 to get me to 4, which would be 18. And then subtract 15 to get me to 5, which 18 minus 15 would get me to 3. So you can see they match either way.